Well, we'll meet again. Don't know where, don't know when. I'll be. Good morning, good afternoon, or good evening to you. It turns out I misspoke on that last section, you guys. I thought that was the end of all of these sections here, except for the honor section. But it turns out there's 3 more chapters to go, so I am excited to have you here with me. Welcome back. Let's go ahead and get to it. All right, we're going to be doing our section 10.1 on secondary math 2 guided notes here, lines and segments that intersect circles. So let's talk about it. A chord is a segment whose endpoints are on the circle. That is, something like this guy I've highlighted in blue. There's your chord. Notice that its endpoints are on the circle. Okie dokie. A secant is a line that intersects the circle in 2 points. So imagine if the chord kept going forever in both directions instead of stopping on the sides of the circle, that would be a secant line. Now, a tangent line is a line that in the plane of a circle that intersects the circle in exactly 1 point. That's your tangent right there. The reason it's different from a secant is that a secant intersects the circle in 2 points, whereas the tangent only just barely brushes it. And then that's it. Now the radius, hopefully you remember that. If not, fret not, sweet children, for I am here to help. The radius of a circle is a segment whose endpoints are at the center of the circle and any point outside the circle. That's this guy right here. Notice that one endpoint is the actual center of our circle, and that the other endpoint is on the circle. And finally, the diameter is a chord that goes through the center of the circle. I want you to notice that the diameter is a special chord. A diameter is a special chord. It intersects the circle twice, but it also happens to pass through the center. Now, a point of tangency is the point to which a line is tangent to a circle. It's that one point that a tangent line intersects. Right here, that would be point B. Tangent circles are coplanar circles that intersect in 1 point. That is, if 2 circles touch on the same point, they have a tangent that goes through that 1 point, they are tangent circles. Concentric circles are coplanar circles that have a common center. They are centered in the same place. That looks like a spooky eye. What color should we make the spooky eye? Let's make it like a dark brown. Yes. There you go. There. Very good. Now, a common tangent is a line or segment that is tangent to both coplanar circles. That is, this tangent lines that you see right above here, these are a common tangent between those 2 circles. There are internal tangents, a common tangent that intersects the segments that join the center of 2 circles, like this. And there's an external tangent, a common tangent that does not intersect the segment that joins the 2 circles. That is, if you take a line segment and connect the 2 circles, the 2 centers, I should say. Let's make that a different color so you can actually see it, shall we? Internal tangents intersect that, and external tangents do not. Here's some theorems that go along with that. In a plane, a line is tangent to a circle if and only if the line is perpendicular to a radius of the circle at its endpoint on the circle. That is to say, there is a radius that if I connect the radius to a tangent line, it's going to be right. And it's got to make sure that it has an endpoint on there, right there. See, that doesn't work with secant lines. You don't have to draw this, but I'm just going to show you here that if I had a secant line, if I were to draw a line that's perpendicular to that, it actually doesn't end on that secant line itself. It ends somewhere else. So that's the issue there. External tangent congruence theorem. Tangent segments from a common external point are congruent. That is, if I had a tangent line, SR, and a tangent line ST to this circle, then the distance SR and the distance ST would be congruent. And you can probably see that because these line segments here are going to be congruent. And I don't know if you remember, because that's the radius, I don't know if you remember that from last time about isosceles triangles. Not from last time, but when we talked about isosceles triangles. Vocabulary. Name two radii. So let's take a look at this. I know you'll probably see the first one. That's probably the easiest one to notice. The first radius I see is AB. So segment AB is a radius. What's another one? Yeah, so there's a couple you could choose from. You could go AF or AD. I'm going with DA. As in, hey DA, how you doing? All right, so name a chord. So a chord, remember, is a segment that intersects the line in two places. Or intersects the circle in two places. And there's a couple of ways you can do that. EC is the most obvious. See, EC has its endpoints right here. But as long as you define it as a segment, you could have also said DE, right? Because if you're talking about the segment D to E, it has endpoints there. And for the record, DF. Because remember, a diameter is also a chord. Name a diameter, FD, or DF, either way. FD, that's a chord that goes through the center, A. You probably should have told us that the center is A. We're going to assume it. Name a secant. Now, that would be a line that passes twice through our circle. And the only secant line that's drawn as a line is line DE. Now, notice when I define it, I'm defining it as a line. That's what makes it a secant instead of a chord. You could have also said line EC. It's just that the line EC isn't drawn there. Let's see here. Also, the line DF. Name a tangent. So that would be, well, boy, it's kind of hard to define this thing because it's only got one point that's on here. So we actually have to put another point on there. Let's see here. Why not A? No, wait, A's already taken. A, B, C, D, E, F, G. There. We needed another point on the tangent so that we could say line GB. Any Packers fans out there? GB, Green Bay? Huh? That one's for you. That one's for you. My wife is a Vikings fan, so she's going to be really mad at me if I say that. So please don't tell her. I name a point of tangency. The place where it actually touches is only point B. That is a place where a tangent line goes through at one time. Of course, any point on the outside can be a point of tangency, provided you draw a tangent line to it. But since that's the only one that's drawn, GB, we're going to go ahead and just say point B. Let's see if I can keep myself out of trouble here for a minute. I'm going to change the colors here to Vikings colors because if she knows that I did something for the Green Bay Packers and not the Vikings, I will be in trouble. Anyway, draw the tangents on the figure. Determine how many total tangents there are, how many external tangents there are, how many internal tangents there are. And I'm assuming it means how many tangents to both circles. So first, let's do the internal tangents, where if you connect these, let's see, we're going to go kind of a, I don't know, that's kind of a goldish color. The internal tangents are the ones that are tangent to both lines, both circles, and intersect the segment that goes through the center. So there are two internal tangents. And then let's see, can we draw an external tangent as well? I think we can. If you take your ruler, let's see. I think I gotta start with this one. There we go, that's better. I'm gonna have to adjust it a little bit. There. Then that would be a tangent there, and then this one would be tangent here. Yeah, and so there's your external tangent lines. There's two of them. And that means we've got a total of 4 tangent lines that go through both of these circles. Okay, let's look here. So internal tangents, well, if you connect these with a segment like this, these circles intersect at exactly 1 point, which means there's only one internal tangent. As for external tangents, let's see here. There you go. There's one of them there. And you can probably see the other one here. I know sometimes you got to do a little bit of adjustment here. It's easier when you have a ruler, which, by the way, I hope you have that today. You're going to need a straight edge and a compass or some way of drawing a circle in order to do today's lesson. I should have mentioned that at the very beginning, but I did not. Sorry. And so there's two external tangents, those, and that leaves a total of three lines that are tangent to both circles. Now over here, there actually isn't an internal tangent. There is no tangent line that I can draw that only touches one circle once and then the other circle once as well, that goes through that connection there. So there's actually zero internal tangents. None. As for external tangents, we've got the plane 2 right there, just like so. So there's two external tangents for a total of 2 total tangents. Again, tangents to both circles. A single circle has an infinite number of tangent lines because you could just draw them all the way around, which actually looks kind of cool. And I guess, actually, I don't know.